Hi students, welcome back to lecture class 1 on milling chapter 2, 5th module, the elements of mechanical engineering course. So today we are going to discuss about the milling, introduction, principle of milling, types of milling machine, specification of milling machines. So in this, unlike lathe uses mostly the round jobs, cylindrical jobs, but here we use flat workpieces, rectangular workpieces, even sometimes we can use circular workpieces also, we can use. So we have to, it is milling machine specially used to make a flat, angular, curved surfaces. We want to cut a gear, we have to use the milling. Using the lathe, you cannot cut the gears. Using milling only, you have to cut the gears. You want to make a keyway slots, you have to use the milling machine. So it is a process of shaping work material by feeding the work material against the multi-point rotating cutter. So here the tool is also multi-point. It is not single point. Tool is a multi-point rotating cutter. It consists of so many cutting edges. This is called a milling cutter. But in lathe we had single point cutting tool. Only single point is a cutting edge. It can also perform drilling and boring operation. It depends upon the cutter depends upon the desired workpiece. What is the shape of the workpiece? So that is the main important thing. So milling is also a machine tool. As I told you, lathe is a machine tool. Milling is also a machine tool. It is used to produce mostly flat, angular, curved surfaces, gears, keyways, slots, etc. The tool used for this milling is milling cutter. It consists of so many cutting points. You can see here. So it is having so many cutting points here. So it's called a milling cutter. And this is the workpiece, a rectangular workpiece or a square workpiece. The thickness is there here. Thickness of some 5 mm or 10 mm thickness is there. And you have to rotate this. Cutter axis, you can say rotation. The clockwise direction is the machined surface. This we have removed. So sometimes the surface of the workpiece is not even surface. Uneven surface will be there. You want to make it even, uniform surface, we can use this milling machine tool and make a uniform surface or flat surface. Flat means what? All the points, wherever you take the point, say at this point it has to show 180 degree. That is straight line. What is the angle of straight line? It's a 180 degree. Wherever you just check it, it should have 180 degrees straight. So your up surface, the down surface, up surface, down surface. It is not a flat surface. Okay, if the up and down surfaces are there, then we say that it is not a flat surface. So flat surface means all the surfaces must be level. Okay, you 180 degree level surface. We call that surface is called flat surface. So you want to make a flat surface, we use a milling machine. For that, milling cutter is used. These are the cutting teeth. So many cutting teeth are there. So work is fed like this. That is the workpiece is moved. In the workpiece totally displaced in the work table, and we have to move this linear feed. Linear feed is given like this. The workpiece is what? Rotating. So just imagine, students, here in the case of lathe, workpiece was rotating. Correct? In the case of lathe, workpiece was rotating, but here tool is rotating. Okay, workpiece here stationary. It is fixed. Firmly it is fixed. It is not rotating on the work table. Okay, it is fixed. It is placed on the work table. So it is stationary here, and tool is rotating. Do you find the difference between lathe and milling? So in lathe, workpiece is rotating. Okay, in milling cutter is rotating. Okay. Next, you see the surfaces. It's a curved surface. See the curved surface here. So this is steep face here. Steep face. This is a T slot. I want to make a T slot on this. The pocket, small amount of metal you have to remove. You have to remove from the surface, the pocket. And angular surface, you want to make an angular surface. We use the milling machine. You want to cut a gears, you have to use the milling machine. So these are the various shapes produced by the milling machine. Next, principle of milling. Very, very important. There are two types of milling is there: up milling and down milling. So two millings are there: up milling and down. First milling. So here cutter is held in the spindle. Cutter is held in the spindle, of the machine and made to rotate at suitable speeds. I have shown you the figure. Cutter is held in the spindle. Okay, the work, so it has to rotate. Cutter has to rotate. Milling cutter has to rotate. So it has to be held firmly. Should not come out from the spindle, and it has to made to rotate at suitable speeds. You can fix the speeds also. The workpiece is also held rigidly by a suitable device and is fed slowly against the rotating cutter. So I have shown here. So this has to be fixed in the spindle, and this has to be fixed in the work table firmly. Both has to be fixed firmly. Firmly means what? It should not come out during operation. It should not come out. Machining operation. So machining operation means what? Metal removal. During metal removal process, the tool, the milling cutter should not come out. It should not come out and hit you. It should not come and hit other people. It should not come. Okay. Workpiece also you have to fix it firmly. The workpiece can be fed. So workpiece, I have shown you that workpiece feed. So we can give the feed in two different directions, and it gives two types of milling. One is up milling and the other one is a down milling. So what is up milling? What is a down milling? You see here, up milling is also called as conventional milling. So now milling cutter is rotating, okay, in the clockwise direction, and the feed is given in the opposite direction. That means the movement of the workpiece in the opposite direction, moves from left hand side to the right hand side. Okay, moves from left hand side to the right hand side. Workpiece movement is opposite to the direction of rotation of the cutter. That is called as up milling. It is also called as conventional milling. Down milling means the movement of the workpiece, that is feed, movement of the workpiece or the feed given in the same direction of the rotation of the cutter. Okay, the movement of the feed is given in the same direction of rotation of the cutter. That is called as a down milling. It is called a climb milling. It is called as a climb milling. Followed. So understood? Up milling and down milling. So in up milling, the movement of the workpiece is opposite to the direction of rotation of the cutter, and the workpiece movement is the direction of the workpiece is same as that of the cutter. It's called as a down milling, and is also called as climb milling. Now differences, we will see differences. What is the difference? Workpiece is fed, first difference is workpiece is fed in the direction of opposite to the rotating cutter, and workpiece is fed in the same direction of the rotating cutter. That you know. Now chip thickness, the case of hub milling, chip thickness is minimum at the beginning of the cut and reaches to a maximum at the end. But here it is different. Chip thickness is maximum at the beginning and minimum at the end of the cut. When the work is completed, the machining operation is completed, at the time you will get the chip thickness minimum. Here chip thickness is minimum at the beginning, maximum at the end of the machining process. Needs greater clamping force. Why? Why needs greater clamping force? Because the movement of the tool is opposite direction of the rotation of the cutter. Thereby what will happen? Cutter starts applying a more amount of force, and then it lifts the workpiece. It tries to lift the workpiece. That is why clamping force is required more. But here it is not like that. Okay, because same rotation, so the workpiece will not lift up. Okay, there is a chances of lifting up the workpiece by the cutter because of opposite direction. So here there is no chances of lifting the workpiece. So needs less clamping force. The accumulation of the chip at the tool work interface damages the surface finish. So that is the problem here in the up milling. So accumulation of the chip, some chip will accumulate in the tool workpiece interface. So there is a damage for the surface finish. You may not get good surface finish. But here chip do not interfere and no damage to the surface finish. So coolant circulation is difficult and coolant circulation is easy. So in this case, coolant circulation is difficult in the up milling. Okay. So in the difficult, why? It means the cutter rotating in the upward direction carries away the coolant from the cutting zone. That is the thing. The cutter rotating in the upward direction carries away the coolant from the cutting zone. But here that is not the case here. So efficient cooling of the tool and the workpiece can be achieved. Coolant can easily reach the cutting zone. So last one is used for rough cuts like casting, forgings, etc. It is used for smooth surface finish. So these are the differences between up milling and down milling. This is very important from the exam point of view. Next, types of milling machines. So first is column and knee milling machine. Next is plain. In that we have two types, A and B is there. Plain column and knee milling machine, universal column and knee milling machine. In plain column knee milling machine, we have horizontal spindle. That's the vertical spindle type. I will show you. This will see the diagrams of these two things. Next is bed type milling machine, planar type milling machine, special purpose milling machine. In that tracer controlled milling machine, thread milling machine, CNC milling machine, etc. But among all these milling machines, we are going to see the figures and discuss about the horizontal spindle type and vertical spindle type milling machine. So coming to the horizontal spindle. Horizontal spindle means you see the spindle is horizontal here. Horizontal arbor is called the arbor. In the arbor we have to mount the cutter. How to mount the cutter here. So the milling cutter. This is called as the overarm, and this is a spindle. So horizontal spindle is there. It's called the horizontal spindling machine. This is a work table. On the work table we have to fix the workpiece. Okay. Work table guideways are there. This is called as a knee. This is called as a knee. Supported by knee. Knee is supported with the knee elevating screw. That means you can make it up and down motions. The arrows shows the knee can be moved up and down. Okay, this is a saddle over which work table is there. Again, you can move this one in this forward and backward direction. This is vertical guideways. This is a spindle. This is a column. In column, we have the mechanisms. This is the overarm. This is a yoke. This is a base. This is a pictorial view. We can see the pictorial view. The overarm. As a spindle. A horizontal spindle. This cutter is there. Milling cutter. This is a work table. You have to fix the workpiece here, and you have to move from this direction to this direction. Moving forward and backward. A saddle. And this is a knee. This is elevating screw. You can lift the knee up and down. That is why that arrow is given. This is a base where entire weight of the weight and vibrations will be carried by this base, and in turn it is fitted a foundation bolts are there. That is not shown. Foundation bolts are not shown here. Just okay. So this is a horizontal spindle, column and knee milling machine. Is the most popular type of milling machine because of horizontal position of spindle is used to cut the grooves, slots, keyways, gear teeth, etc. So here base. First is you are seeing here base. Say it should be strong. It is a hollow part. It is strong. It is a hollow part which forms the foundation of the machine, and upon which all the other parts are mounted. So it should be a strong, because all the other parts are there. It should be a strong one. The base also serves as a sump for lubricating fluid. It is cutting fluid. You can use cutting fluid also. It serves as a sump. It acts as a reservoir. You can keep the cutting fluid inside this base. A pump and filtration system can be installed in this base. Okay, the hole provided in the center of the whole base houses the support for the elevating screw that rises or lowers the knee. Okay, next is column. Column is a vertical hollow casting. So it is a vertical hollow casting. It is usually combined with the base to form a single casting. Both are single casting. So column is a casting, base is also casting. Both are single casting. In the column you will have spindle, bearings, some mechanisms, drive units are there, gears, clutches, shafts, shifting mechanisms for transmitting the power from electric motor to the spindle. So that is to transmit the power, okay, from spindle to the arbor. Arbor has to rotate. As the arbor rotates, cutter also will rotate. So mechanisms will be their entire mechanisms. Next, spindle is a hollow shaft supported by the column with the suitable bearings that absorbs the both radial and thrust loads. The spindle is made hollow and tapered inside to accept the standard arbors. Okay, you can change the arbors also. Whatever the arbors you want, depending on the milling cutter, depending upon the size of the cutter, we can change the arbors also. Standard arbors. The spindle obtains power from the motor and transmits it to the arbor. So arbor carrying the cutter rotates about the horizontal axis. Next, overarm. You can see the overarm here. So overarm is mounted on the vertical column. It supports the yoke, which in turn supports the free end of the arbor. Because free end you have to support this. That is why overarm is given. So free end of the otherwise it becomes a cantilever. Arbor it becomes like a cantilever beam. So knee is a casting that slides up and down on the vertical guideways provided on the column by means of an elevating screw. The knee supports the saddle. Next, what is saddle? What is the saddle here? What is the meaning of saddle? Saddle it is mounted on the knee, provided with the two slides guideways on its top and bottom surface. The slides are machined at right angles to each other. The lower slide fits the slide provided on the top of the knee and facilitates the horizontal movement of the saddle. The upper slide provided on the saddle accepts the slide provided on the bottom surface of the work table. Next, work table. So work table is a bit larger in size. So work table larger in size and rest on the saddle. So bottom surface. The bottom surface of the table has dovetail slide. You can see dovetail means you can see dovetail shape. This is called as a dovetail shape. So dovetail slide that fits in the slide on the top surface of the saddle. This arrangement facilitates the work table to be moved longitudinally at right angles to the movement of the saddle. Okay, the work table is provided with the T slots. It has a work table is having a T slots are there. You can fix the work pieces along its length for mounting the vise or other work holding devices. So this enables the workpiece to be clamped rigidly on the table. So a dial graduated in thousandths of the inch is provided. It is not shown in the figure. For accurate table movement and placement. So this is all about the horizontal spindle column and knee milling machine. So next we will go for the horizontal photo here. This is the arbor. This is called as arbor. This is the milling cutter inside is there. This is the overarm. This is a column, and this column. This is a base. This is a work table. This is a hand wheel. See, you can see the holes, T slots, the graduations are there. This is knee. You can see knee elevating screw here. All the parts. So this is a saddle. Horizontal spindle. So arbor is horizontal direction. Next is vertical spindle column. So vertical spindle. So you have the vertical spindle. Vertical direction spindle is there. You can see the vertical spindle. Cutter is there here. Spindle head. Swivel type. Saddle. Work table. Vertical guideways. Column. Base. Support. Elevating screw. Say everything is same, but spindle is vertical direction. Is cutter and milling cutter. So in the spindle here, similar in construction to the horizontal milling machine, except the spindle is in the vertical position. It is generally used to perform end milling and face milling operations. End milling and face milling operations. The details regarding spindle used in the vertical milling machine is first one is spindle. Spindle is located vertically parallel to the face of the column and perpendicular to the top of the work table. This permits working on angular surfaces of the workpiece. That's all about this vertical spindle. You see the photo. So here the vertical spindle is there. Work table. This is a base. This is a column. Next, specification. How can you specify the milling machine is the following ways. Criteria. First is type of spindle. What type of spindle is there? Next, length and breadth of the work table. Power of driving motor. Number of spindle speeds. Spindle feed range. Taper of the spindle nose, etc. So these are the criteria we can specify the spindle. This one, vertical milling machine. Thank you for watching the video. Again, we'll meet in the next lecture class 2. That is the lecture class 2 on milling machine. We'll talk about the various operations that can be performed in the milling machine tool. Thank you.